but at a rather, I must say, rather superficial level, so that hopefully in future, if you need to dig deeper, you have some background into knowing about these. Okay, so we are talking about these. Last time we will start with these 5 topics first about the bulk material, as we have done in the past, and then we will move on from the bulk to 2-dimensional system, such as the surfaces, and what will be unique in that case. Now, of course, when we talk about electronic structure for the bulk, we have reference, and the reference will be solid-state physics and solid-state chemistry. This topic has been developed for a while, and so a lot of these materials come from solid-state physics and chemistry. Okay, so you could definitely check relevant essentially any solid-state physics or solid-state chemistry textbook will have a lot of these material in it if you need some references to look up. So first off, last day as well, we were talking about this periodic table that most of us as chemists we know. And we talked in first year chemistry about these guys here, right? These guys here, and then now, and in the first part of chemistry, first year chemistry, we talk about metal as well, particularly crystal structure and so forth. And one of the things that not talk about is this electrical property, electrical or electronic. I guess electrical will be a better word because we are talking about conductivity and resistivity. Electronic tends to mean structure and so forth. So these are electrical properties. Is one of the physical properties that you can measure with some digital voltmeter that one may have in the lab. And one thing that I commented is that this property, these particular physical properties, that has a wide range. One of the widest range of any physical property, 10 to 32, from one end of the periodic table to the other ones. And you could see, interestingly, these, notice the scale here. The conductivity has been multiplied by 10 to the 5th, and conductivity 10 to the 5th, and resistivity 10 to the -6. So it's micro ohm unit, micro ohm centimeter unit. This is usually how one is measured. And ohm centimeter, 1 over that, 1 over ohm centimeter is called Siemens. Siemens is just basically inverse of this unit, and that's the unit for conductivity. So it's rather straightforward in that sense. And if you look in this periodic table, is of interest to notice why all our household are wired with copper wire, and it's because, of course, copper wire has a very high conductivity, has a low resistance, and is among the highest. Second to only silver. Gold is up there. Gold is the third. This row of material is really very important in that sense, because this is give you conductivity, pass current through anything in terms of construction material and so on. So you can check here, right? You can check this, and you really cannot find anyone that has more conducting compared to silver or copper, and they are rather interesting. And as we will see later, copper and gold, for example, copper and gold, they are different in their appearance. Of all the metals that you see, they are different in appearance because they have this yellowish color, right? The typical yellowish color, whereas all the metal are basically shiny black type, metallic type material. Only copper and gold have this distinct another interesting point. And one interesting thing about gold, of course, is that you often find that gold is used in high expensive electronics. You want, like, you buy a TV connector, right? This connector that you have in the TV for tee off your signal, and you pay a lot of money for gold-plated connector. And why is that? Why not because of appearance for its own sake? Is that gold has a special property that what they call surface resistance. You just measure a thin layer of gold. That resistance is actually the lowest. In other words, if you're just talking about a very thin layer of material, if you just measure surface resistance, that material is very good. Whereas copper, of course, the problem with copper is that, as with all the other copper, it forms copper oxide on the surface. It easily oxidized. You found a black coating with time with your copper, and the surface resistance becomes poor with copper oxide. And that's the reason. And gold does not form oxide in air. So this is why people use gold for high-speed electronics and things like that. Silver, on the other hand, silver also forms oxide, but the oxide itself is conducting. It's not as conducting as silver itself, the metal itself, but it is conducting. So therefore, it's okay. But really, why people use copper is because of cost. It's just much cheaper than gold or silver. And the recent earthquake in Chile, if you remember, Chile produced about 30% of the copper. And so if you have any earthquake in that region, the price of copper will go up, because then you would worry about these things, about economics, because they produce 30% of the world copper. Okay, so we have these properties of interesting. And the conductivity, I point out here, conductivity is inverse of resistivity, it's just 1 over. And the other point about this is that temperature effect. So for copper, they all change with temperature. The resistivity all change with temperature. So for example, for copper, the resistivity at 4K, liquid helium temperature, is about 100,000 times less, 100,000 times less that of room temperature. So the resistivity goes down, the conductivity goes up. Right? So as you cool your metallic material, they all behave like that. They all have this temperature dependent that as you cool more, the conductivity will increase, whereas the resistivity, of course, will go down. In non-metallic material, however, like insulator, plastic, or some of these guys on the other side of the periodic table here, these are molecular solid, then it's the other way around. In fact, when you cool, the resistivity goes up, and you become less conducting as you lower the temperature. So only for metal, it has, when you cool, conductivity goes up. The other one, non-metallic, behave in the opposite way. Okay, so that's one thing. So that's resistivity, one thing. The other thing is, of course, this crystal structure that I point out here. This table is very nice because it gives you all the crystal structure that you see. This periodic table. Hopefully you can. Let me see if we can focus a little bit. So you notice that all these FCC, HCP, and BCC, essentially, if you look at the metallic section here, there's only 3 types of, there's actually 3 types, right? So you have BCC, FCC, and HCP. And then if you go on to this side, you have other one, like a diamond, and so forth. The other one that's starting to come out. But for metallic, this part here, you only have this type of structure. You don't have, interestingly, you don't have simple cubic in this metallic crystal structure. Okay, so that's another thing that you can think about in this way, and this is another way of classifying your element or your metal based on the crystal structure that it has. Okay, so of course, why we need to talk about crystal structure, because the crystal structure, which is how you arrange your atom inside a periodic lattice, it is important that we talk about in physical structure because it will control, as